Hi, I'm Michael Smith from Bad Weasel Games. One of the things I do in a lot of my games is to combine 2D and 3D elements. So for example, I might have a backplate that's just a 2D plane, and then I'll have 3D elements over top of that. Another example would be to have a heads-up display or maybe some kind of UI element that is made up of 2D sprites. And so in either of these cases, to make the elements look as sharp as possible, I want these objects to be pixel perfect. So if it's a backplate, I want the backplate to be the full size of whatever the device is and to be a pixel perfect thing that I create in Photoshop. Or in a 2D game, or with the other sprites, sometimes I want those to be pixel perfect, and then they might get smaller on a bigger device or something. But in a 2D game, you can do that with an orthographic camera, and in what I'm learning here is in Unity you can use the pixels per unit to do that. But even in 2D games, I like to be able to fly things in from Z-space. So even two-dimensional objects or something, have them fly in, and that gives them, and I like those to have perspective. So with an orthographic camera you wouldn't be able to do that because moving things closer to the camera doesn't change their size. So this is how I solve the problem. I did have a way of doing this in my own engine, and so here I've translated that to Unity. So this is my test project, and this is using a perspective camera. So you can still have pixel perfect sprites in a perspective camera. There's just a trick to doing it. And so the trick is that you have to place the sprite in the exact Z depth to make it appear pixel perfect. So and like I said, I've done that in my other games before. But here's my project. I'm going to switch to the scene view, and I have two cameras set up. I have a perspective camera, and then I have an ortho camera. And so, and then I have this sprite that I made in Photoshop. And let me flip over there. So here's the sprite in Photoshop. It is a shown at 100%, and you can see it's a pixel perfect. I have these little lines in there so we can see that those lines should look sharp and crisp. So I brought that sprite in, and it's a 256 by 256 pixel sprite. So here's the sprite in my scene, and I have these two cameras. Now I have the sprite set to pixels per unit is 100, and this can work for whatever pixels per unit you set, but for this demo I just have everything set to 100. So that makes the 256 pixel sprite be 2.56 units wide. So if we look at our game view, this is 2.5 units wide. So in my project, let's start with the orthographic camera. So let's look at these two cameras. So I've got this camera set up, and you can see that the depth doesn't change the perspective. It's all, no matter how deep you go, it's all the same. And then, so this is the frustum on that. And then if you look at my main camera, is this perspective camera there. And so what I did is I put the cameras side by side so that the one camera shows it over to the side. So if we look at the two cameras together, you'd see the sprites be side by side, so we can compare them. Right now in my game view I have the main camera turned off. So let's see. So let's run this. I have the main camera turned off, so if I run it, I've got everything set dark so that we don't accidentally. So I've clicked to my sprite, and if I take my Z depth and I move it around, it doesn't change the apparent size of it. It always stays the same. If I switch to my scene view, you can see that even when we move this, it doesn't change anything. You still see it the same size. I also have a little script running on this camera that sets the size to be right. So that is my ortho camera script. So if we go over there, basically it takes the screen height in pixels, I guess, and then divides by half of the pixels per unit. So this 100 is that pixels per unit. I found this formula online, but when the project starts, it sets it to that, and when we look, so even if I change, my ortho camera is set to 3 right now, so even if I change this to a different size, you know, that would make this not pixel perfect any longer, but as soon as I run it, it pops it to the right size because it runs that script, and that right size is 3. So basically what I did was I just found out what it is by running the script, and I just set it to 3 so that it's right to begin with. And that is because my resolution is 800 by 600. If I had a different resolution, then it would have to change the size to match that. So it's really half the height. So this size is the height, but it's really only half the height from here to here, because we're at 600 pixels and we're at 100 units, 100 pixels per unit. That would be the total height would be 6. So it would be 600 divided by 100. But the size factor is half of that, so it's 3. Okay. So if we flip to Photoshop, you can see, so even if we have this running, okay, and then we flip over to Photoshop, you can see that the two look pretty much the same. Let's see, where's my zoom in? So if we zoom in, you know, they look pretty much the same. So I think, to me, that's pixel perfect. Okay, and that's with the orthographic camera. So now let's add the main camera in. So I'm going to stop this. I go to my main camera, and I will enable that. And now with the main camera enabled, it just so happens that at the moment it's set up here. But so we have a perspective camera, and I'm starting with my field of view at 45. And so if we change, so if we run this, okay, and if we change the field of view, you see that Sprite changes size based on the field of view. And if we switch to the scene, you can see that that frustum is changing. Go over here. That frustum is changing, but the object is staying at the same place. So if we set this, and the same thing happens if we change our sprite and we move it, go to the game view, and we move the Z depth of the sprite, we can set it to where it's about the same. So we can get it to where it looks pretty close. Okay. So if we were to set the camera, the main camera, at a field of view of 45, okay, and then we go to our sprite and we set that to where it's the same, that's about 7 point something, 7.26 is what I have it set to right now. So so you can do either one. You can move the field of view to look, you know, you move the field of view to where it looks the same size, or you could move the sprite scale, or Z depth rather, to be the same size. So you can do either one of those things, and you can make it look the same. So I have a script that basically figures out this number. So there is a Z depth at which, for any field of view, so we can test that if we go and change the field of view to 60. Okay, now it's smaller, and then we go to the sprite test. We can change the sprite size to be, I think it's 5.19 is what it says now. So we can find a Z depth for the sprite that makes it look pretty pixel perfect. If we zoom in on this, it's pretty close. I mean, there's a little bit of, it's not exact yet, but we can make it exact in code. So let's look at the script that does this. And the way I've always done it is I use the projection matrix to do it. So I have this on my main camera. I have this script on here called Unity Depth. And if we go to that, this is what I have. So I've got a Unity Depth static, and I've got a focus. And then when it starts, it finds a unity depth. And then it just finds the value. It's not doing anything to anything. It's just finding a value and putting it out there. So a way that it works is I first create a view projection matrix by taking my projection matrix and my world to camera matrix, which is that's the view matrix and the projection matrix, and then I create the view projection matrix from that. And then I need to know my screen width in units. So my screen width's but half the screen width in units. So we know that we're 100 pixels per unit. So we take the screen width in pixels and then divide that by the pixels per unit and then divide it by 2 to get half of the screen width. That gives me half the screen width in units. And so basically then we just take the first element of, so this element of the matrix, the first element of the matrix is the X scale. So I gotta look at my thing here. So that is the X scale factor of the view projection matrix. That's going to affect the scale in the X direction. And then the fifth one is actually the Y. So this is the X, that's the Y, and this is the Z scale factor. So my focus Z, my unity depth, which I named before I was ever using Unity, is the depth at which away from the camera, the distance away from the camera that will make that sprite look pixel perfect. So we take that Z factor, that X factor times the width, which is actually half the screen width in units, and that becomes our depth. And then we get our focus Z is where do we place it? Well, that's just taking the camera's position minus that distance away from the camera. And so then I debug that out. So I see what are those two values. And then just as a sample, I do the same thing using the height, and I calculate it that way. So using the height instead, and that uses the fifth position in the fifth position in the array in the matrix, which is the Y scale factor. So that's doing it using the height, and I log that out. And then Marco suggested this other way. In the Unity docs he saw this thing, and so I checked that out. And that is that you can calculate the distance required to give a specific frustum height. So here's the formula for that. And so I took that formula and I used that formula. Mine's slightly different because, let's see, they're taking the height of the frustum times 1/2 in units, and my height already is half because I already divided by 2 there. So I don't have to divide it by 2 because it's already divided by 2. So here's that formula there, and I calculate it that way. So that this is just calculating the distance, and I stick it in this static so I can access it from somewhere else. Okay, so then the next part of the script is in the sprite itself. And what I have in there is I have a thing called set sprite depth. So here's my set sprite depth. And basically that takes, I just have a Boolean so I can flip it on and off in code if I want. So if that's on, what it's doing is it runs that find the depth in my Unity depth script. So in the camera script, it goes ahead and finds the depth, and then we just move the sprite to that depth. And I'm doing that every frame just for the demo. So let's see how that works. So let's get it running here. I'll go back to my sprite, get that running. And in my sprite, I'm just going to, we'll start without it running and just show you that if you move that, field of view, it is obviously changing the frustum changes, and so the apparent size of the sprite changes. Okay. But if we go to that sprite, flip that script on so it's running, it pops into place. So now we can go back to our camera and we can move that around and see it doesn't, moving that field of view doesn't, every frame it's changing the, to be in Unity. So when we can switch to, bring up the Photoshop so we can see how it compares to the Photoshop. And here it is in all three. So you can see that when we change that field of view, doesn't matter where we change it, it is setting that. And then let's show you on the scene view how that works. Let me move a little bit. So as I change that, you can see that it's moving the sprite to always be where it needs to be pixel perfect. And of course the ortho camera, you know, when I change when that sprite moves, it's moving for the ortho camera as well, but it doesn't matter where it is there, it's always the same. It always looks the same on that camera. So there it is. In practice, I wouldn't call this every frame. I would only call it when at the beginning. So I would just call this at the beginning. I set it, find that Z depth, and then set all my elements that I want to be pixel perfect to that Z depth, and then they will be, and then render them in whatever order I need to. So there you have it. And I go back to just so you can see the scripts again. My ortho camera script is this formula that I found online just for setting the orthographic size, which again is half the height of your thing. And then my Unity depth one is here, and basically you can do it any one of these three methods. Oh, I guess I didn't show that. Let me show you that. This is kind of good too. If I go to my console and I slide this camera around, you can see that the depths change, but all three ways of calculating it show the same. So here we'll move it to, I'll zoom in so you can see that. I don't know if you can see that or not. Let's see. So all three ways of changing it the same. So you have three different calculations are making it be the same Unity depth of 2.18. So, and then even if you move the camera, that focus Z is going to be that distance away from the camera. So as long as the camera is pointing straight. So if the camera is pointing in a different direction and not straight, then that's not going to work. You'd have to calculate the distance using vectors and not just the depth only. So this is assuming that the camera is pointing straight ahead. But you can use any three of these methods. You can either do this projection, this method where you grab the projection and then you get that. Or another way is doing it this way that's on the Unity docs here. You can do that way, either one. Essentially they're doing the same thing because this tangent of the F field of view is how you calculate the matrix when you're making projections. So that's how that's done anyway. So that's it. And then on my set sprite, I just have this. If I'm fixing the depth, then I do that. But probably what I would do is I would just move these two lines to the start and only do it once, and not set it every frame because you don't need to once you set it. All right, there you have it.